Hi. Welcome to this week's edition of Cosmology. Without further ado, let's get started. Sun. The Sun is the Solar System's star and by far its most massive component. Its large mass, which comprises 99.86% of all the mass in the Solar System, produces temperatures and densities in its core high enough to sustain nuclear fusion of hydrogen into helium, making it a main sequence star. This releases an enormous amount of energy, mostly radiated into space as electromagnetic radiation peaking in visible light. The Sun's temperature is intermediate between that of the hottest stars and that of the coolest stars. Stars brighter and hotter than the Sun are rare, whereas substantially dimmer and cooler stars, known as red dwarfs, make up 85% of the stars in the Milky Way. Elements heavier than hydrogen and helium were formed in the cores of ancient and exploding stars, so the first generation of stars had to die before the universe could be enriched with these atoms. The oldest stars contain few metals, whereas stars born later have more. This high metallicity is thought to have been crucial to the Sun's development of a planetary system because the planets form from the accretion of metals. Interplanetary medium. The vast majority of the Solar System consists of a near vacuum known as the interplanetary medium. Along with light, the Sun radiates a continuous stream of charged particles known as the solar wind. This stream of particles spreads outwards at roughly 1.5 million kilometers per hour, creating a tenuous atmosphere that permeates the interplanetary medium out to at least 100 astronomical units. Activity on the Sun's surface, such as solar flares and coronal mass ejections, disturbs the heliosphere, creating space weather and causing geomagnetic storms. The largest structure within the heliosphere is the heliospheric current sheet, a spiral form created by the actions of the Sun's rotating magnetic field on the interplanetary medium. Earth's magnetic field stops its atmosphere from being stripped away by the solar wind. Venus and Mars do not have magnetic fields, and as a result the solar wind is causing their atmospheres to gradually bleed away into space. Coronal mass ejections and similar events blow a magnetic field and huge quantities of material from the surface of the Sun. The interaction of this magnetic field and material with Earth's magnetic field funnels charged particles into Earth's upper atmosphere, where its interactions create aurorae seen near the magnetic poles. The heliosphere and planetary magnetic fields partially shield the Solar System from high-energy interstellar particles called cosmic rays. The density of cosmic rays in the interstellar medium and the strength of the Sun's magnetic field change on very long timescales, so the level of cosmic ray penetration in the Solar System varies, though by how much is unknown. The interplanetary medium is home to at least two disk-like regions of cosmic dust. The first, the zodiacal dust cloud, lies in the inner Solar System and causes the zodiacal light. It was likely formed by collisions within the asteroid belt brought on by gravitational interactions with the planets. Inner Solar System. The inner Solar System is the region comprising the terrestrial planets and the asteroid belt. Composed mainly of silicates and metals, the objects of the inner Solar System are relatively close to the Sun. The radius of this entire region is less than the distance between the orbits of Jupiter and Saturn. This region is also within the frost line, which is a little less than 5 astronomical units from the Sun. Inner planets. The 4 terrestrial or inner planets have dense, rocky compositions, few or no moons, and no ring systems. They are composed largely of refractory minerals, such as the silicates which form their crusts and mantles, and metals, such as iron and nickel, which form their cores. 3 of the 4 inner planets have atmospheres substantial enough to generate weather, all have impact craters and tectonic surface features, such as rift valleys and volcanoes. Mercury. Mercury is the closest planet to the Sun and on average, all 7 other planets. The smallest planet in the Solar System, Mercury has no natural satellites. Besides impact craters, its only known geological features are lobed ridges or roops that were probably produced by a period of contraction early in its history. Mercury's very tenuous atmosphere consists of atoms blasted off its surface by the solar wind. Its relatively large iron core and thin mantle have not yet been adequately explained. Hypotheses include that its outer layers were stripped off by a giant impact, or that it was prevented from fully accreting by the young sun's energy. Venus. Venus is close in size to Earth and, like Earth, has a thick silicate mantle around an iron core, a substantial atmosphere, and evidence of internal geological activity. It is much drier than Earth, and its atmosphere is 90 times as dense. Venus has no natural satellites. It is the hottest planet, with surface temperatures over 400 degrees Celsius, most likely due to the amount of greenhouse gases in the atmosphere. No definitive evidence of current geological activity has been detected on Venus, but it has no magnetic field that would prevent depletion of its substantial atmosphere, which suggests that its atmosphere is being replenished by volcanic eruptions. Earth. Earth is the largest and densest of the inner planets, the only one known to have current geological activity, and the only place where life is known to exist. Its liquid hydrosphere is unique among the terrestrial planets, and it is the only planet where plate tectonics has been observed. Earth's atmosphere is radically different from those of the other planets, having been altered by the presence of life to contain 21% free oxygen. It has one natural satellite, the Moon, the only large satellite of a terrestrial planet in the Solar System. Mars. Mars is smaller than Earth and Venus. It has an atmosphere of mostly carbon dioxide with a surface pressure of 6.1 millibars. Its surface, peppered with vast volcanoes, such as Olympus Mons, and rift valleys, such as Valles Marineris, shows geological activity that may have persisted until as recently as 2 million years ago. Its red color comes from iron oxide in its soil. Mars has two tiny natural satellites thought to be either captured asteroids, or ejected debris from a massive impact early in Mars's history. Asteroid belt. Asteroids, except for the largest, Ceres, are classified as small solar system bodies and are composed mainly of refractory rocky and metallic minerals, with some ice. They range from a few meters to hundreds of kilometers in size. Asteroids smaller than 1 meter are usually called meteoroids and micrometeoroids, depending on different, somewhat arbitrary definitions. The asteroid belt occupies the orbit between Mars and Jupiter, between 2.3 and 3.3 astronomical units from the Sun. It is thought to be remnants from the Solar System's formation that failed to coalesce because of the gravitational interference of Jupiter. The asteroid belt contains tens of thousands, possibly millions, of objects over 1 kilometer in diameter. Despite this, the total mass of the asteroid belt is unlikely to be more than 1,000th of that of Earth. The asteroid belt is very sparsely populated, spacecraft routinely pass through without incident. Ceres. Ceres is the largest asteroid, a protoplanet, and a dwarf planet. It has a diameter of slightly under 1,000 kilometers, and a mass large enough for its own gravity to pull it into a spherical shape. Ceres was considered a planet when it was discovered in 1801, and was reclassified to asteroid in the 1850s as further observations revealed additional asteroids. It was classified as a dwarf planet in 2006 when the definition of a planet was created. Asteroid groups. Asteroids in the asteroid belt are divided into asteroid groups and families based on their orbital characteristics. Asteroid moons are asteroids that orbit larger asteroids. They are not as clearly distinguished as planetary moons, sometimes being almost as large as their partners. The asteroid belt also contains main belt comets, which may have been the source of Earth's water. The term Trojan is also used for small bodies in any other planetary or satellite Lagrange point. Hilda asteroids are in a 2-to-3 resonance with Jupiter, that is, they go around the Sun 3 times for every 2 Jupiter orbits. The inner Solar System also contains near-Earth asteroids, many of which cross the orbits of the inner planets. Some of them are potentially hazardous objects. Thank you for watching this video. If you liked this, please give it a thumbs up and subscribe for more such contents.